So the first topic in this course is matrix algebra, which some of you may be an overview, but we'll go from first principles. Matrix algebra. And basically we'll give you the applications with the business application in mind. Really, that is when it makes sense to you. So that is the matrix. The simplest definition for a matrix is an array of numbers. An array of numbers with k rows and n columns. In fact, this k here, you can always, if the most commonly used number of rows is general number of rows is m rows and n columns. So in the context of matrix algebra, when we see m, we know you're talking about rows. When you see n, we know you're talking about columns. We know rows run from left to right. Left to right. Columns run top down, not vice versa. Then a matrix is normally denoted by a square bracket, not a standard bracket, square bracket. Square bracket, both sides. That is a matrix. So the number of m and n that makes up a matrix is called its dimension. So a matrix dimension are the number of rows and the number of columns. Note that I'm not talking about number of columns and number of rows. I'm talking about rows and columns. Rows and columns. Again, conventionally, matrices are normally denoted by a capital letter of the alphabet. A capital letter of the alphabet. Letter A is a matrix whose members, whose elements are A11, A12, up to A1n. Remember, we have n columns. Row 2, A21, up to A2n. Row 3, row 4, up to row k. In fact, this k here is what I'm calling m, the last row. AMN, AM1, up to AMN. So this is a matrix, which can also be condensed in this form. The curly bracket, this is a curly bracket, Aij, subscript, where I moves from 1 to m. In this case, I'm calling this m. And j moves from 1 to n, n columns, n columns. J are the columns, j is the jth column, I is the ith column. So when I is 1, j is 1, is A11. When I is 2, j is 2, j is 1, A21. So these are column 1 elements. Then you have column 2 elements. Then you have column n elements. Row 1 elements, row 2 elements, up to row m elements. K is m. That's what I've just told you. So that is the general form of a matrix, any matrix. Now, types of matrices, types. Let's go to types first. Types of matrices. And I want you to take a pen and paper. Types of matrices. Number 1 is a rectangular matrix. A rectangular matrix. Rectangular matrix. A rectangular matrix of dimension or order m by n. Of dimension or order m by n. I'm talking about m by n. M by n is written this way. It's not m times n, but m by. Use the multiplication sign to denote the order or the dimension. I'll just write it somewhere here. Bracket m by n. A rectangular matrix is a matrix of order m by n where M is not equal to, it's not equal to sign, you know, not equal to sign, you have this equal sign here, and then cross it with a vertical line, not equal to N. When M is not equal to, this one needs to cross this by using a vertical line. So a rectangular matrix is a matrix of order M by N, where M is not equal to N. And I'll give you examples of a rectangular matrix. M is not equal to N. For example, 3 by 2. 3 are the rows, 2 is the columns. 3 by 2. Remember, it is not 3 times 2 is equal to 6. No, it's 3 by 2. The multiplication there is basically when M is equal to 3 and N is equal to 2, then it will be 3 by 2. That is a rectangular matrix because the number of rows is equal to the number of columns, whichever. And there are a number of such matrices, So I'll give you some examples here of a 3 by various rectangular matrices, Probably I'll just pick these ones here. This one, just look at these matrices here. This one. Here, we have got 2 rows and 3 columns. So this is a rectangular matrix. For example, write this. Let A be equal to 3, 6, 4, 7, 1, 0. Rectangular matrix of order 3 by 2. Again, this is also 3 by 2. This is also 3 by 2. You can also write 2 by 3. Give your own examples of 2 by 3. Remember, these elements are aligned by row and aligned by column. So if this was A, so A11 will be 3, A12 will be 4, A13 will be 1, A21 will be 6, A22 will be 7, A23 will be 0. So that's an example of a rectangular matrix. When M is not equal to N, the number of rows is not equal to the number of columns. Is a rectangular matrix. Type 2. Square matrix. Let B, capital B, just write that. Let B be a square matrix of order M by N. Or B is a square matrix of order M by N. B is a square matrix of order M by N. M by N is here. Of order M by N, where M is equal to N. The number of rows is equal to the number of columns. The number of rows equals the number of columns. So as long as you have a matrix where the number of rows is equal to the number of columns, then you have a square matrix. For example, B, I'll just use this, write this, B equal to, with a square bracket, 3, 4, 1, 6, 7, 0, then 1 to 1, the last row, 1 to 1, 3, 4, 1, 6, 7, 0, 1 to 1, the last row. So that is a square matrix because the number of rows is equal to the number of columns is equal to 3. So you'll have a 2 by 2 matrix, you'll have a 3 by 3 matrix, you'll have a 4 by 4 matrix, a 5 by 5, but for you, the maximum, and you'll see why the maximum you can never go, is a 3 by 3. Your applications will only end at 3 by 3. You not go to 4 by 4. It becomes a bit complicated unless you're using Excel or other applications. So that is a 2 by 2 matrix, a 3 by 3 matrix. You could also have a 2 by 2 matrix. You can also have a 3 by 3, 4 by 4, 5 by 5. It doesn't matter. So that's a square matrix. Number 3.
Excuse me, sir.
Yes.
There are people in the waiting room.
Yep.
There are people in the waiting room waiting
okay.
to
Sorry.
yeah.
But the waiting room is not locked, eh? It's not locked. It's very open, actually.
Oh, it's not locked?
Yeah, it's not. Let them just come in, eh?
Okay, thank you.
Yeah. Yeah, let me just come in. Let me just check. It's not actually.
Okay.
Just check. Yes, Samu. Your hands up.
No, it was on that issue. Let me lower it.
Yeah, then put it down, eh? Put it down, eh? There's nobody there in the one person in the waiting room, but I don't know why what is taking outside there. It's not locked. Just send him a text, eh? Send him a text to enter.
Okay.
So now that is a 2 by 2, 3 by 3. And remember, these types of matrices I'm giving you are selected types because you're going to use them in the area of application. So that is type 2. Type 3, identity matrix. Identity matrix. Now, let me give you some explanation first. For a matrix to be an identity matrix, then it must be a square matrix. For a matrix to be an identity matrix, it must first be a square matrix, meaning that it's only square matrices that can be identity matrices. This is a special type, therefore, of square matrices. Now, the structure of an identity matrix, the structure of an identity, just write small note. These things are here, but just short notes. Eh? The structure of an identity matrix depends broadly on two diagonals that make up a square matrix. Two diagonals that make up a square matrix. The structure of an identity matrix depends on two diagonals that makes up a square matrix. Two diagonals that make up a square matrix. Let me see whether I can get a typical square matrix here. A typical square. Don't worry about those things. I'll deal with them in a minute. Square matrix, square matrix. I'll get you a square matrix. I'll just go to Excel and I'll tell you what you do. Then I'll show you the diagonals I'm talking about. Two diagonals that make up a square matrix. So what are these diagonals? I'll show you in a minute. Let me just open Excel so that you can see what a square matrix is, what an identity matrix is. Now, I'm sharing Excel. So it's taking time to share, just to enable you see how I'm generating the matrix and then its corresponding identity. So this is Excel. That is Excel. So I said that an identity matrix, the structure of an identity matrix depends on the two diagonals that make up a square matrix. So what are these two diagonals I'm talking about? I hope you're seeing Excel. Let's look at, let me give you an identity, a 2 by 2 matrix. 2 by 2. 2 by 2 matrix. 2 by 2 matrix. And I want you to write it this way. A. So capital A, sorry, is the matrix. Then you have got 2 here. Yeah, I will give you the elements of this matrix, 1 and 2. Then 5 and 3. 5 and 3, whatever. Remember, you need to put and close this in a square bracket. This one here, I mentioned in a square bracket. But the matrix is A equals to that. Now, this matrix here is a square matrix because it's 2 by 2. the diagonals that make up this matrix are only two. There's diagonal that runs from top left to bottom right. Top left to bottom right. This diagonal that runs from top left to bottom right is called a leading diagonal. Leading diagonal. Well, this diagonal that runs from bottom left to top right, bottom left, top right, is called the lagging diagonal. Lagging diagonal. So this is the leading diagonal. This is a lagging diagonal. So the elements of leading diagonal are 1 and 3. Elements of lagging diagonal is 2 and 5. That's a general 2 by 2 matrix, square. Let's go to 3 by 3. And let's write for you 3 by 3 here. 3 by, so that you see the equivalent identity. So let B be a square matrix, B. And this matrix is, and remember, you must enclose this in a square bracket. I'll continue saying that. 3, 4, 2, 0. This is a 3 by 3 matrix. Enclose this in a square bracket. This side square bracket, that side square bracket. This is a 3 by 3 matrix. 3 by 3. 3 by 3 matrix. And I told you this is the maximum you'll go, but I'll go to 4 by 4. I'll go for you 4 by 4. 4 by 4 matrix, which is a square matrix. 4 by 4 is this type here. This is one of the most important types of matrices. 4 by 4. Let it be matrix C, capital C.
Is it from my end? Or...
What?
It disappeared kidogo. So that's 4 by 4, 4 by 4, 2 by 2, 3 by 3. These are general square matrices. Remember, I said that an identity matrix can only be a square matrix. So what is the square equivalent of this? A square, now you write this, a square matrix is that matrix with all the elements in the leading diagonal as 1. All the elements in the leading diagonal as 1. The rest, 0.
So can you repeat?
A square matrix, an identity matrix is that matrix where all the elements in the leading diagonal is 1. Here, the leading diagonal here is 1 and 3. So if this was square, an identity matrix I, let's call it I, then the identity matrix here will be, this will be 1, that will also be 1, but the rest will be 0. That is an identity matrix of order 2 by 2. 2 by 2. All the elements in the leading diagonal is equal to 1. The rest are 0. That's what an identity matrix is. In fact, you derive an identity matrix from a square matrix. That's what we do. And we'll show you how to derive an identity matrix from a square matrix. So with this, therefore, can somebody tell me what will be the equivalent identity here? Can somebody give me the equivalent identity here? Which are the elements in the first column? Elements in the first column? Anybody?
1, 0,
1,
0.
0, 0. Second column?
0, 1, 0.
0, 1, 0. Third column?
0, 0, 0, 1.
0, 0, 1. That's a square, an identity matrix of order 3 by 3. Dimension 3 by 3. I want you to take, because this is really the core of application of matrices, the use of the identity matrix. Give me the, what about the first column here? The first row. The first row is what? Somebody, first row?
1, 0.
1,
0, 0.
0, 0, 0. The next one is what? I'm on rows.
0, 1, 0, 0.
0, 1, 0, 0. The third one is what?
0, 0.
0, 0.
1, 0.
1, 0. The last one?
0, 0,
0, 0.
0, 0, 0.
0. 1.
You see the elements leading diagonal are 1, the rest are 0. That is what an identity matrix is. And we derive this from a square matrix. Any question, please? And for you, the maximum you'll ever go manually is 3 by 3. This one becomes very complicated when you are using it, but you'll have to, I'll tell you how to solve large problems with 4 by 4, 4 by 4 rows, or 5 by 5, or 6 by 6. You can use computing, you use applications anyway. So that is an identity matrix. Next is column matrix. Column matrix. Column matrix. Let's just call it E. E is a column matrix. Column matrix of order. Of order. You know the order now. M by what? N. Such that N is equal to 1. It means that it only has 1 column. That's a matrix with only 1 column. 1 column. Number of rows can be as many, must be more than 1 anyway. 2, 3, 4, 5, it doesn't matter. For example, this is E. And please enclose these things in a square bracket. I'll repeat, equal to, you must put equal here. Equal to what? I'll write them here, 5, 2, 1, 2, 3. This is a matrix. Enclose this in a square bracket. What is the order of this matrix? What's the order of this matrix? Anybody? What's the order of that matrix?
5 by 1.
5 by 1. So this is a 5 by 1 matrix. 5 by 1. That is a column matrix. And the converse for a row matrix is true. The converse is true for a row matrix. F is a row matrix. Row matrix of order M by N such that M is equal to 1. So here, F is equal to, sorry, F equals to, I'll just write it here. 4, 2, 3, 1, 4, sorry, and say 6, 7. These ones disappear. Just giving you examples. And then you close this in a square bracket. I'll continue repeating that. Not normal bracket, but square bracket. In matrices, normal brackets mean other things. Square brackets are these brackets. Yeah, this one is a square bracket. That's a square bracket. This one is a square bracket. And this one is the closing one. Sorry, this one is the closing one. Square bracket. So this one would be A here. That, and then this side here, that. Now, I've seen people trying to put commas between elements of matrix. No comma. You write them this way. You write them that way. Because matrix is an algebra. It's algebra, really. So that's F. That is a column, a row matrix. Any question? Yes, sir. Yes, yes. Are you talking to us or you are talking to your people at home? If you are talking to people at home, you leave. So now, so that is row matrix. So these are the major types of matrices that you will apply in your business area. Types. Next is matrix operation. I'm on the slides. Don't worry, I'm on the slides. I'm going down the slides, but I want to do them here. We'll do the slide, we'll review. We'll review. Let's look at matrix operation. Matrix operation. And I want you to write the following general statement. Just write the general statement. It's in your slide, but write the general statement. That just as I'm now on matrix operation rate. Matrix operation. Matrix operation. Then you write that. Just as there are operations of, I'll let one hang a bit, leave space there, leave some space, of, in normal number algebra, normal number algebra. We have which operations do we have in normal number algebra? Edwin, which of the algebraic operations do you have? Normal number algebra. How do you operate on the numbers? What do you do with the numbers?
Add, subtract, multiply, or divide.
What is the acronym for the operations of normal number algebra? What's the acronym for all the operations of normal number algebra?
BODMAS.
BODMAS, which now is not really not BODMAS, but E-BODMAS. E-BODMAS. So we have the operations of E-BODMAS. E-BODMAS, where E is a raised to a power, exponentiation. You deal with the number raised to a power first before you do bracket, before you do of, before you do division, before you do mass, M and AS. So just as there are these operations in normal number algebra, there are also the following operations in matrix algebra. Matrix algebra. These are the only operations you have in matrix algebra. Number one, addition. You add matrices. Number two, subtraction. Of course, BODMAS will still work. The order will still remain the same. But this is the main operations we'll deal within that BODMAS. Then number three, multiplication. Multiplication. Number four, now, we don't divide matrices. We don't divide matrices. We invert matrices, inversion. And then number five, transposition. Transposition. To transpose, transposition, sorry, T. Transposition. So that's the operation of transposition, to transpose. So those are the five operations you have in normal number, in matrix algebra. And those are the operations we are going to deal with now, but through an example. So now let's start with the first one, addition. Addition. Then you will go back to your slide and review addition. So how do you add matrices? Two or more matrices. Two or more matrices. Say matrices. Say A and B and B can only be added, can only or is compatible with addition. Come on, addition, addition. With addition, can only be added. Added, where is added? Can only be added, which is the same as is compatible with addition if they are of the same order. They are of the same order. Order or dimension. dimension. They are of the same order or dimension. That is, you can only add 2 or more matrices if they are of the same order. In fact, I want to combine this because it's the same. Addition, stroke, subtraction. It's the same, rather than wasting time. Or subtraction. Subtraction. I hope this is being recorded. Trust so. Yeah, good. So 2 or more matrices A and B can only be added, stroke subtracted. Stroke subtracted. I.e. compatible. Subtracted. I.e. compatible with addition or subtraction. It's the same thing if they are of the same order. Otherwise, you can't add them. For example, let's take A. I'll pick any matrix here. A. I'll just pick any matrix, square matrix. 2, 3, 4, 5. Remember, these elements can also be negative. 1, 0. Then say, and that is it. What's the order of this matrix? Remember to put a square bracket. What's the order of this matrix? Matrix A. What's the order? What's the order here?
3, 2.
3, 2. Is that the order?
2, 3.
No.
2 by 3.
No, 3 by 2.
3 by 2. You don't use your own terminologies. 3 by 2. That is so. Then let's consider another matrix B. B should be which order? For it to be added to A. Which order? What are these statements?
3 by 2.
3 by 2.
By 2.
So I'll have my B here. Let's just copy this anyway. That is my B. Can be anything. I can even make this one negative. It can be negative, doesn't matter. This could be 6. This could be 8. Whatever this one is, 4. Then let the rest remain. 3 by 2. That is A and B. And that is when you can add them, when they are of the same order, or subtract them. So let C be the sum of A and B. Let matrix C be the sum, C be the sum of A and B. Let C be equal to A plus B. So what is C equal to? Now the procedure. Yes, please.
You said I've understood the same order, but what does same dimension mean?
The same. It's the same thing. It means the same thing.
Okay, thank you.
Yeah. That's another term for order.
Yeah.
And that's how I started up there when you talk about dimension or order. So that's good. So now let's get A plus B. So therefore our C. So now the procedure, right? The procedure is to add corresponding elements in A and B. Add corresponding elements in A and B. Corresponding elements in A and B to get C. So C is equal to, I'll just write it for you here. C equals to, is like this. I'll just pick A. This is our A. It doesn't matter where you put your A. That is your A. And this is our B. That is our B. Remember the square bracket and then plus. You add them. You add them. Plus A plus B equals to. What are the corresponding elements? Which element will, what will be the sum here? What will be the sum here? Here.
2 minus 2.
Which is what?
0.
0. What will be here?
4.
4. What will be here?
9.
9.
9. Here?
2.
2. Here?
12.
12. Here?
10.
10. That is A plus B. Remember, I'll repeat, put this in square bracket. All these matrices. Of course, write them properly. This is Excel I'm using myself. So that is C. Remember that C, B, A plus B is the same as B plus A. Is there any difference?
No.
No.
No difference.
No. A plus B is equal to B plus A. That's a very important property of matrix algebra. Very important. Let's go to D now. Let D be equal to A minus B. D. Let D be equal to A minus B. Remember, it's the same procedure. So I'll just pick this. I'll pick that. That is A, B, and I bring it here. And then minus corresponding elements. Sorry. Corresponding elements.
0. No. 4.
Let's do this first here. So that's fine. That's fine. I want to get this space here. That you get what I'm saying. Remember, put those in square brackets, minus. So what will be here?
4.
4. Here.
Negative 4.
Minus 4. Good. Here.
Negative 3.
Negative 3. Here.
0.
0.
0.
Here.
Minus 4.
Minus 4. And then what?
Minus
0.
0.
Is that okay?
Yes.
Yes. Remember to put this in a square bracket. I'm repeating this. This is not idle talk. Now, what is the order of C? What's the order of C?
3 by 2.
3
3
by
by
2. Beautiful. It's 3 by 2. And there's a reason I'm saying that. 3 by 2. The order in C will be same as the order of A and B. Similarly, the order of D will be the same. Will be the same order as A and B. So that is addition. Now, I want to ask you a question. Is A minus B the same as B minus A?
No.
No.
A minus B is equal to what? What do you do to get B minus A from this matrix? Suppose this was E. So what is E? What is A minus? What's B minus? What's A minus B minus A equal to? What would you do to this matrix? This one.
Let me try. Okay, for you to get E, you will take C plus B.
I know you're a Kenyan. Where are you from? Where are you from? We are asking very simple questions. Very simple. You know what I mean? But it's a good try. When you told me you're trying, and I know that what you're just seeing it and easy. I've just pointed here. How do you get B? How would you get E from here? Are you seeing where I'm pointing? From here. Yes, Ozzy.
Multiply by -1, I think.
Nothing else. Multiply by -1. So I will simply multiply this matrix here by -1. Easy. And I'm done. And that's it. Then you will have gotten E. Is that okay?
Oh, you can't do. Oh, okay.
Okay.
But you can do B minus A.
But after you have gotten A minus B, and then you ask to find B minus, must you do it again? You simply say A minus E is equal to -1 times that. That's mathematical manipulation. Math is supposed to make life easy.
Yes.
Yes, not too complicated, not to go long path writing again B minus A like this. I'm just giving you shortcuts of getting the so it means that Subtraction is not compatible with an, it's called an associative property of matrix. Associative. You'll see to the other side. Don't worry. The other side in your presentation. While addition is A plus B is the same as B plus A, but A minus B is not equal to B minus A. That's what it means. So now this is addition. Now you can add any matrix under the sun, can't you? The only thing you have to note here is that they must be the same order. The other thing you have to note is that you add the corresponding elements, and you're done.
Yes.
That is addition and subtraction. The next one is what? Is which one?
Excuse me, sir.
Yes, please.
Yeah, kindly, I have another class. So
Where? Why?
the
Which class
class
is this?
end at 3.
Are you,
We end.
all of you have another class, eh?
Yeah.
Yes.
Oh God.
Yes.
Oh God. Oh God. Now, but I thought it was 3 hours. Eh?
No.
No.
Anyway,
It's
so
1
because
hour
we can't
40
interfere with the other lecturers' work, eh? Just note that we will start with multiplication on Thursday. Thursday I'm
Yes.
free. Thursday we'll start with multiplication. But you go and
Yes.
let me post this for you now. Just now the presentations. Then now you go back and review matrix algebra. What we have done.
Yes.
That's fine.
Sir,
That's okay.
I have
So-
a question.
Yes, please. Yes, please. Ask.
Can you also post this Excel that you just did today?
Oh, you will get it. This one you will get via YouTube. Eh?
Oh, okay, that's fine.
Yeah, you're not getting it. You are not post it. You will get it via YouTube.
Yeah.
Okay, sir.
Thank you, sir.
Okay, sir. So go to class. That's fine. We'll meet on Thursday.
A good day, sir.
Now you remind me to post it, if you just in case, remind me to post these things, the class rep,
Yes,
remind
sir.
me,
Okay, I don't have
if
the
you
number.
come from class, if you don't see it, then just remind me. I'll make sure I post it today, yeah?
Okay, can I have
Everything.
the number?
My number is 0712
Uh-huh.
293
Yes.
891.
Okay.
That's out.